Today we're going to look at polynomial long division. So we're going to do both polynomial long division and synthetic division on polynomials. And I know that most of you have seen this in previous years. It's just that this year we're going to apply this to different things. So to start, we're going to look at an example. It says recall 46 divided by 7. So this is the same, we're actually using the same algorithm that we've used for long division. So 46 divided by 7, if we do that, we would get 6 and then a remainder of 4 out of 7. So we're going to be using that same idea, but doing it with polynomials. Okay, so let's look at our first one. 6x squared minus 26x plus 13 divided by x minus 4. All right, so these problems are really hard to look at once they're completed. It's hard to know where all the numbers came through, so I'm going to try to go slowly through explaining this. We take our first value under our sign, so then 6x squared, and we're going to divide that by x. So 6x squared divided by x is 6x. And then we multiply this 6x by x minus 4. So 6x times x is 6x squared, and 6x times negative 24, or negative 4 is negative 24x. And then what we have to do is flip our signs. So if you remember, we have to make that a negative sign and make this a positive sign. Then we add. So 6x squared minus 6x squared is 0. Negative 26x plus 24x is negative 2x. Then we drop this 13 down. And then we do this again. So we're going to take our negative 2x and divide it by x. Okay, so negative 2x divided by x is negative 2. Then we do the same thing that we did with the 6x, where we multiply it by x minus 4. So negative 2 times x is negative 2x, and then negative 2 times negative 4 is positive 8. And then we flip our signs. So we're going to have a negative 8 and a positive 2x there. 2x minus 2x is 0. 13 minus 8 is 5. Okay, so the way that we would write this answer, if I use that form that we have where it says recall, it's going to be whatever is on top of our division bar, which is 6x minus 2, plus a remainder of 5 over our divisor, which is x minus 4. Okay, let's do our next thing. So this ramps up pretty quickly. So the division algorithm, we're just using the dividend, divisor, quotient, remainder, which is, we already worked with those in that last example, and now this is asking us to put them in specific forms. So here is one form, not like that. Here's the other form. So you have two ways to write these, and we'll just, you just write them out the way that the text tells you to. Okay, so we have p of x and d of x, and all we're going to do is divide those. So it says find polynomials q of x and r of x such that p of x equals d of x times q of x plus r of x. All that means is to plug in the things that you get into that form. So I'm going to go through this. 8x to the 4th plus 6, made a mistake already. So you have to watch this if you have a power that is missing. So this is going x to the 4th, x to the square to the 2nd. So we're missing a cube. So when we write these out, we have to have a placeholder. So we're going to write 0x cubed plus 6x squared minus 3x plus 1. and that's divided by 2x squared minus x plus 2. And so the problem's a little bit more involved than the last one, but it's the same process over and over again. So we're going to take 8x to the fourth, divide it by this first term. Okay, so that would be 4x squared. Then we multiply that back through. So 4x squared times 2x squared is 8x to the fourth. 4x squared times negative x is negative 4x cubed. And then 4x squared times 2 is 8x squared. And then we flip our signs. So we're going to go minus, plus, minus. And then we add. So 0, and then we'd have 4x cubed and negative 2x squared, and then you drop one term. Next, we take 4x cubed, divide it by 2x squared. So we would get 2x. Make that a positive sign. And then again, we go back and multiply 2x by our divisor. So we would get 4x cubed. 2x times negative x is negative 2x squared. And then 2x times 2, which is 4x. Then we flip our signs. Okay, and so the cubes and the squares would cancel, and we would get negative 7x. And I don't think I mentioned this in the last example, but you're done when your degree that you have at the bottom here, that's degree 1, and this is the degree 2, your divisor. So when you have one less degree, that is when you're finished. Okay, so this whole q of x, r of x, p of x, d of x, all that stuff. So this is your quotient, which is your r of x, not r of x, q of x. This is your remainder. Okay, this is your divisor. And so this just wants us to write them in this form that I underlined. Okay, so the polynomial, this is kind of an irritating process, but I'll do it anyway. 8x to the fourth plus 6x squared minus 3x plus 1 equals the divisor times the quotient plus the remainder. I'll switch that sign. Okay, so if I just highlight that one more time just to be clear about it, this is p of x, this is d of x, this is q of x, and this is r of x. Okay, synthetic division. Let's see here. So synthetic division is where we just strip off the coefficients, and this is the one that everybody usually likes a lot better. Okay, so we just take the coefficients of all of these and draw an upside down division sign. Some people draw that differently or make it a different symbol. And then we just write these. So again, if you have a power that's missing, you have to write it in. So this would be 2, negative 7. We have x's, no x's, and then we have a 5. whatever you're dividing by. So we're dividing by x minus 3. What this means is that it's going to be the opposite of whatever it is. So if it's x minus 3, then you are going to flip the sign on that. So this would be 3. And then we do this. Draw a line, drop the first term down 2. Then multiply 3 times 2 and put it beneath the 7. So this would be 6. Now we add negative 7 and 6 to get negative 1. And then we do that process again. So exactly like we did the first time, we multiply 3 times negative 1 and put it here. Then combine those, and then we do it again. So 3 times negative 3 is negative 9, and then we combine those. Okay, so the way that we wrote out the last example, we're going to do that again. So this would be, I'll write this different. So P of x equals, let me make sure I got that form right. The divisor times the quotient. And so my quotient is this bottom line. So the quotient is going to be 1 degree less than what we started with. So it would be 2x squared minus x minus 3. So I'm taking these numbers right here and just attaching variables in descending degree. And then our remainder is negative 4. So this would be plus negative 4. I'm actually going to write the polynomial out here. So what we started with was 2x cubed minus 7x squared plus 5. So this is P of x equals D of x times Q of x plus R of x. Okay, so the remainder theorem and the theorems that we add on to this stuff, what's nice about it is it changes nothing about how we do the problems. We just have to interpret it. So it says if the polynomial P of x is divided by x minus c, then the remainder is the value P of c. So what this is saying is that if we divide a polynomial using synthetic division, our remainder value is going to be the same number as if we were to plug the number in. So let's do this one. This would be, we're dividing by 2, and it's 2, 0x squared, 4x's, and then a constant. So drop your 2, multiply 2 times 2 is 4, combine, and do that process again. 2 times 4 is 8, this is 12, this is 24, and this is 26. So the value here, 26, that's the same thing as if we were to go P of 2 and plug that into our polynomial. So we can check. So what I'm saying is P of 2 is 26, and now we're going to check that. Well, P of 2, we would replace 2 in all of these. And does that add to 26? So 2 cubed is 8 times 2 is 16 plus 8. 16 plus 8 is 24 plus 2 is 26. So the remainder theorem just says that your remainder is the same number as if you were to plug it into the function. And so you can calculate these really fast using synthetic division. So this one, it's pretty easy to plug it in and calculate, but if you had a string of 10 terms, synthetic division would be a lot easier. Okay, so the factor theorem is this. C is a 0 of P if and only if x minus C is a factor of P of x. So if we look at the remainder theorem, this last entry, the remainder 26, is the same as though we were plugging in a number. So this is just an extension of that. So if 1 is a factor of p of x, then we're going to get a 0 in that last spot. So let's just go ahead and do this one. So take off your coefficients. So 1, no x squareds, -7, and 6. And we're showing that 1 is a factor. Okay, so we drop the 1 down, multiply 1 times 1, combine, multiply 1 times 1, combine, multiply 1 times -6, and combine. So this entry of 0 means that we divided it and it was evenly divided. So if we were to write this out, I'm going to write it out like this. X cubed minus 7x plus 6 equals, our factor that we were checking was 1. So x minus 1. And then our bottom line, our entries right here, represent the rest of our polynomial. So we would have x squared plus x minus 6. And if we can actually factor that one more time, for -2 and +3. Okay, so what we're saying with this is that we can use synthetic division to factor polynomials, and it makes it a lot faster, and it also makes it so we could factor any polynomial, well, virtually any one that's factorable.